an actual talk. That's the whole talk in reverse. So I decided to title this talk "The Architecture of Python." That's my job title. That's what I work in, software architecture, and I don't know how necessarily accurate this is. This is intended to be for talk for programmers, introducing them to Python, perhaps some of the features maybe you're not aware of. But so we're going to cover the language marketplace, why I originally chose Python as my prominent language, Zen and the style of Python, how Python supports object-oriented and functional programming, so some other things I mentioned in the meetup outline, the architecture of CPython, and how we can use modules and integrate packages, and some other features of Python. So I think the biggest, most attractive thing when I chose Python was the idea that there should be one obvious way to do it, because it seemed like with all these programming languages out there that I could choose from, there were so many different ways you could do things. So you could do, I would ask somebody, okay, so how would you do this in your language? And they would say, oh, you could do it like this, or you could do it like this, or you could do it like this. And so all those various ways of doing things means that's more that you have to learn. So I figured with Python, I'd have a lot less that I'd have to learn in order to be able to say I know Python. The licensing, it is open source, and everything is also free from a cost standpoint. Whereas with some programming languages, you have to pay for licensing, you have to pay for IDEs just to be able to compile it. So I really liked how Python was free and open source, and I'd be able to actually look at the source code that was running on my machine. It's a high-level programming language. There are fewer lines of code to get things done. That means that I can focus on, more other things other than space allocation, memory allocation. Cleaning up things when they're done. If Python will automatically clean that up for me, that's less I have to worry about, less I have to learn. So that was a huge reason I chose Python too. It's batteries included, has a very large standard library. If you need to accomplish something, someone's pretty much, you just have to imagine that someone's waved the magic wand and made it happen with Python. So there's usually libraries. The standard library is huge, and there's this Python package index, which is basically a repository of even much larger library of packages that you can install and use to get things done with Python. It was really popular even back in 2002, which is when I was learning it. It wasn't popular in business, but it was really popular with programmers and really smart programmers. So that means that if you had run into a roadblock, you had problems, you could probably get some help, or even with various extensions of the language, there's probably somebody who you could find who'd be able to help you. It's readable. People describe it as executable pseudocode. It has very simple grammar and syntax. It does allow for overloading of operators, but it's still, even in spite of that, it's quite simple and easy to read. And I think all of that adds up to making it more maintainable. If you're doing the right things, you're following best practices, you're using descriptive names, you're writing tests, Python is extremely maintainable, whereas with some languages, the code is write once and heaven help you if you need to modify it in the future. Correctness. So by correctness, I mean as a function of readability and the ability to reason about the code at a high level. When you write with Python, your code should be very correct. If you know Python, and it's because of these things, it's easy to learn Python. It's easy to write correct code, assuming you know how it works, and scoping and things like that. And Python is also, we are currently moving towards gradual typing. We're not there yet. We're just at the point where we're saying, okay, you can say what things that a function expects and what it returns. So we're going to see if other implementations of Python are going to be able to utilize this so that we can maybe build code that's written in pure Python and in executable Python, build that as C code or in other languages that are statically typed.
For the ignorant among us, what is the last point? Gradual typing?
That is so gradual typing is where you can include typed functions with and variables and things like that in your Python code, and it would execute inside of your Python code.
Okay. So some of it are typed, some of it strongly typed.
So some of it could be typed, and some of it could be strongly could be
weakly typed.
Dynamically typed.
Dynamically.
And so and we don't have that yet. We're moving towards it. Maybe Python might be. Maybe we could say that Python has that. So when I chose Python, Python was a new entrant to business. Due to its amazing qualities, which I just covered, I figured business should be using it. They're using all these horrible languages. They're using them incredibly and effectively and efficiently. I think, okay, Python is going to have make a huge impact in business. So I was like, it's a no-brainer. Let's go with Python. Only the smartest programmers were using it, but that meant you could say, okay, this is a useful shibboleth, so we can determine who's the smartest programmers. Probably the ones that are talking about Python and are learning languages that we're not using as a requirement of their job, but will make their jobs a lot easier and make them more effective at their jobs. So here's the market share today, or at least some measures of the market share. And I think there are others, but these popped up first in my Google image search. This big green blob here, that's Python. And this is from Codeval, and so I think this is like kind of an indication of learners of new languages. We're going to see them using tools like Codeval to learn, and so this is probably not the share of everything, but this is probably a good indicator of the pipeline of new learners that are coming into the programming world. I think we have a huge pipeline of Python programmers coming to us from computer science programs and things like that. So, and when you look at that relative to C++, Ruby, Java, the others aren't even coming close. And then we have the Stack Overflow rank versus the GitHub rank, and there's Python way over on the top right. It's got a little bit higher rank than Ruby on Stack Overflow. I think Ruby's its main competitor, but Ruby is kind of beating it in terms of number of GitHub projects. Anybody have any idea why that is?
Maybe they just do them small ones quicker and safer.
Maybe small, quick ones. Yeah. I want to know if for this ranking, did they count, say for example, people who clone, like for the Hartle tutorial? I don't know.
Web programs.
Web
programs.
Web?
Yeah, programs.
Web programmers? They're going to use GitHub more than Python programmers?
Yep.
I don't know. I don't know why Ruby is showing more so on GitHub than Python, but I suspect there's a sneaky reason.
It could be measurement error. That's not a big.
Well, this is rank. This is rank. So that is so these are like the top 100, I believe. And I think it's significant enough to maybe care about it. But
Is there a time range there?
But you know what, the point, yeah, this is just the rank. This is from 0 to 100, 0 to 100. Yes. Yes, as opposed to this chart, this one actually labels the axes. So.
What kind of means? If something is higher on GitHub, then people do stuff in the language. If it's higher on Stackoverflow, people ask more about the language.
On Stack Overflow, people are asking more about the language.
Right, so it's like it's the ratio of doing to like ask.
Ratio of doing to asking. Okay, that's funny. I don't know. I think
That's why SQL's so high. People write a lot of code in SQL.
And XML. They do, it's just not, they don't.
if you look at my profile on GitHub, it's going to say that I've got some Ruby repositories because I did the clone of for things like the Hartle tutorial, and I don't use Ruby. I wouldn't claim to be a Ruby expert.
So how much does it say that you do Ruby based on just Hartle?
I don't know. But what I'm saying is that counts as a project for me. So if that counts as a project for me, does it count as a project for this ranking?
Totally.
There's definitely a time factor there too. If you look at some of the languages that are listed, right? Or
Yeah.
steep decline.
These were. I made sure to get the ones for this year. So.
On your ranking though, you see there are things that are appearing that are just not used much anymore. XQuery, right?
Oh, sure.
Right? So that
Yeah.
would be a factor.
Yeah, I'm pretty sure these are like posts on Stack Overflow all time.
Okay.
Anyhow, the main point.
There's no C++ in there.
It's got to be in there.
It's crammed
Yeah,
in there.
it's squashed. It's right
No,
there.
C, before Python.
Do we see it?
Oh, yeah, Python, C++, CSS, yes.
Objective-C and C.
Oops, sorry.
Yeah, they got all mine.
There are a lot of C's there.
There's CSS, there's Objective-C,
Yeah,
there's C.
Java, right behind JavaScript.
I don't know.
Wow.
Is that it overlaid with Python?
Yeah.
Oh, yeah, yeah.
There it is with the pluses. Yeah. Yep. Okay. So the whole point of this is Python has killer market share. That's the point of this. And you guys have gone for 4 years, and this is the first time we've done Python. That's great for me. So I feel sorry for you guys, but this is great for me that I get to do it.
Ubiquitous.
I get the in languages Python talk. That is awesome. Thank you guys.
Richard did one. We did do it like 2 years ago.
No way.
I'm pretty sure.
I
No.
don't think so.
No, we got to look at the history.
Yeah.
They keep the history.
Yeah. I know.
Well, the Bible, there's the Bible, and the 7 languages are Bible, that's why.
Yeah.
It wasn't in the.
And it wasn't in the 7 language book. I know. Yeah.
No, it wasn't. When 7 languages came out in 2009, Ruby was much more obscure than Python.
Yeah.
But back in high school, and I graduated in '98 from high school. I was learning about Python and Ruby, that they existed, both of them at the time. I proposed to my math teachers that it was quite possible to have a language where you didn't have to declare the types, and the program could infer them, and the programming language could infer the types. And she declared that was absolutely impossible. I found out, yes, actually, we can do that.
She wasn't aware of BASIC?
I don't know. BASIC had some weird typing stuff that was frustrating to me.
I don't remember declaring types in BASIC.
Okay, so Python has killer market share. People use Python for Python. So I know we got some people who really like Ruby here, but I would put out there, go out on a limb maybe, and suggest that people don't use Ruby for Ruby. Maybe they use Ruby for Rails, and there's a couple of DevOps tools that they use Ruby. Puppet and Chef, yeah. But people use Python for Python. And so that's part of what I envisioned when I originally picked Python as my what I wanted to focus on. So I think less open software is kind of a risk. We just had Oracle try to take away Java headers, and they failed. But you know, if I had gone into Java in a really big way, and I was doing Android development in a really big way, and all of this relying on everyone telling me, "Hey, Java's open source," I would have been really unhappy. I'd have been really unhappy. There's no danger that's going to happen with Python. So again, Python used to like signal, these are the best programmers, but I think the signal is now a lot weaker. Now we have a lot of new people coming into as programmers. Python's their first language. I think you know, like MIT, you know, students are increasingly learning Python as the introductory language. So I think it's less of a signal in that respect. Okay, so of course we have Python for the web. We have Flask, we have Django, Tornado, Twisted, which is still being ported from Python 2 to Python 3 because Python 2 native strings are these 8-bit these 8-bit byte strings basically. And in Python 3, the native string literal is the higher level Unicode type, and so that's sort of a little bit of a higher level than UTF-8, which you'd want to sort of universally move strings around in, and because of that, we have a lot of obscure parts of Twisted that need to still need a lot of work. But it's happening. It's in the bigger parts are working in Python 3. There are a lot of organizations that are still in Python 2, and they're going to be on Python 2 for a long time. Python for data analysis. We have NumPy. Started out as numerical Python, and now it's NumPy and the Python package index. We have SciPy, which builds on top of that. Pandas on top of that. Stats models, scikit-learn. We have all these great tools for data analysis. Okay. I don't have all the answers, but I do have some of them. You cut off all my answers. I can fix that.
I'm more curious about the questions.
Yeah. I just have to do that. Save, compile. Wait for it. There we go. Yeah, all right. I got some answers. Notice the hand-drawn red circles.
Snapchat?
No. This is kind of a meme on Stack Overflow. It's usually things that are wrong. You want to have the hand-drawn red circles, but you know, thought it was apropos. I'm at 25.5 million people reached. That's pretty cool, and it's mostly due to Python. And I don't think that's actually people that I've personally reached, but I think it's a good relative measure of my impact on the site itself, on the quality and scope of the content that I've created on Stack Overflow. I've got a lot of really great answers on there. I'd encourage you to check them out. If you're looking for a popular Python question, Control F and then type in Aaron, and maybe I've got a good answer on there. Okay, so I'm sure everybody's heard of Python. Has probably heard of the Zen of Python, or maybe you've looked into it a little close. Okay, so Zen of Python. Tim Peters was one of the core contributors of Python. It's basically a lot of people like to cite it as guidance in how you should write your code. But the problem is each consecutive line kind of contradicts the prior line. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules, although practicality beats purity. Errors should never pass silently, unless explicitly silenced. In the face of ambiguity, fuse the temptation to guess. There should be one, and preferably only one, obvious way to do it. And there's more. So I think it illustrates the principles that sort of intention that guided the development of Python. I would suggest that you be aware of anybody touting the Zen of Python, particularly one line, to justify their very likely bad code. And what you should think of when you think Zen of Python, you should think of a few snarky programmers sitting around one-upping each other with off-the-cuff aphorisms. PEP8. Okay, so PEP8 is the Python style guide. It's basically what's required to get code into the standard library. It's got to be written to this standard, and it's evolved a little over time. Beware. So I would be aware of anyone who poo-poos this Python style guide PEP8 too much. It is really good style. So I think the Google's Python style guide incrementally improves on it. I would suggest, really get your Python working well. Use a linter like Flake8 and get the warnings to 0.
I have a question.
Yes.
What's Flake8?
Flake8 is a linter.
I thought
Is Python like
PEP8. Well, PEP8 is a spec, and you can get a linter to be PEP8 compliant.
Well, so it would help you get your code to be PEP8 compliant. It'll also fix things that PEP8. It'll address things that. So there's a package called PyFlakes. There's a package called PEP8, and basically what they do is they cram them together in a single package.
Because my understanding was that Flake8 suggested and linted things beyond PEP8.
It should. It probably should.
Yeah.
What I'm saying is it's been sort of subsumed into Flake8, along with the PyFlakes package. So Flake8's kind of like the standard linter. You can add things if you need to. All right. So Python supports both object-oriented and functional programming, but it's object-oriented at its core. It does support most of the features of functional languages, but certainly not all of them. And if you expect to use it as you would a functional language end-to-end, you'll be disappointed. So everything is an object in Python. For example, functions are compiled into objects as well with certain attributes. Like we call this double underscore because these appear on special methods and special attributes in Python a lot. We call these dunder. We call them dunder methods. So dunder short for double underscore, and usually the ending underscore is implied. So that would be pronounced dunderdoc. We have multiple inheritance. That's kind of a scary concept for some languages. The diamond problem is solved. We use what's called the C3 linearization algorithm. I could do a little mini lecture on that right now. We're at 7:30. I think we'll just keep going. This is where I was going to pull out the whiteboard and work through a complicated inheritance tree. Yeah, we could do that. Or hey, you got a little conference room here. I could draw on that if for people who are interested.
Has crayons.
And the bar has crayons.
Yeah.
I love crayons.
But if you say a word about the diamond problem, for those who are a bit more ignorant, I've never heard of the diamond problem.
You've never heard of the diamond
Never heard
problem.
of it.
It's nothing to be ashamed of.
Okay, thank you.
The diamond problem basically states that if you have a child class with a couple of parent classes, and maybe they share the same parent, it's too complicated for us to sort out the method resolution order for those classes, and I say poo on that. There's a paper called method linearization algorithm for Dylan, something like that, which gave us the C3 linearization algorithm. Python was one of the first adopters of that. You can also get it in Lisp. I made sure you could. I asked when you gave your Lisp talk.
They solved it a long time.
Yes, it's been solved. It has been solved. So you can get C3 in Lisp. So functional. So we have lexical scoping for closures. Most functions, so we have a lot of functions that are built in, like map and filter. If you're a user of functional languages, yes, no. Reduce.
When we call it fold.
We've really actually sort of subsumed map and filter into list comprehensions and generator expressions. So it's actually been discussed getting rid of the map and filter functions, but too many people think in those terms, and so I think taking it out of the language would handicap them. We don't want to do that. So we're leaving in map and filter. So we do have recursion limits because recursive calls add execution frames to the stack. And do I need to explain all this? No?
So there's no tail call optimization?
No.
How would you, so they're considering removing map and filter? Or they've considered it?
That they've talked about it. They're not going to, though. The resolution is they're not.
And is that because there's a different way to do a map other than using map function?
That's a for loop.
Yes.
Oh.
List comprehensions, generator expressions. I'm going to get to that. So, all right.
So how fast is a function call? So if you do a recursion, so you do a recursion, so every time you call a new function, so what's the over?
Okay, so say a function calls itself, right?
Yeah. So how many operators?
So when the function is called, it creates a frame that's added to the stack, and then the function calls itself, which creates another frame that's added to the stack, and then the function calls itself again, which adds another frame to the stack, and eventually you're going to run out of memory.
There's no additional overhead in calling a function versus calling another function. It's just that.
No, it's a general question. It's not.
As long as you don't run out of memory, you're fine. As long as you don't run out of memory, you're fine. You can extend the recursion limits to the size of your memory.
Okay, I'm not specifically asking about recursions.
Right.
General function calls. How long
Yes.
does it take in Python? How long does it take?
Is there a cost for using functions?
Oh, is it a cost?
So if you call it,
It's a little bit of a cost.
is it what?
It's negligible. I'd focus on writing good code and not worry about the cost of a function call. And profile your code.
You have to create a stack.
Profile your code. Optimize for the bottlenecks. You see where your code's spending the most time, and that's the philosophy in Python. In Python, the philosophy is prototype. Write your prototype in Python. Try to write good Python. Write your prototype in Python. Do it with test-driven development if you like, and then if that meets your technical requirements, you are done.
I don't think you'll ever get to the point where the function call overhead is significant in Python, because you're going to have to do type dispatch anyway. And
Is it significant or is?
You'll get to the point where it is significant.
Right. So it's not significant.
Yeah.
It's not really worth worrying about.
But okay, I saw a demonstration where it turned out to be very significant. So it takes like 100 nanoseconds or maybe 1,000 nanoseconds
Yeah.
just to call a function.
Yeah.
And the guy who was giving that talk was actually not measuring that.
No, I could show you how to profile, and we could look at that together.
It seems like that
Yes.
most of the time was spent actually on function calls.
Right. So
So it was low.
I wouldn't carry away that lesson from this discussion, though.
I have
Yes.
a really quick question. So is recursion considered bad style in Python?
Is recursion bad style in Python? No, I've got answers on Stackoverflow that are getting lots of upvotes that involve recursion. I think recursion is a great way to solve a lot of problems.
As long as you're aware of the gaps.
Yeah, as long as you're aware of the limits. I haven't found the recursive limits unless I'm just writing my code wrong. And it's a lot more efficient to write iterative code in Python than as opposed to writing recursive code. Which maybe you saw that in my functional talk. We discussed that about the efficiency of that. No? Okay. Mixins. Ruby has mixins, right? Ruby doesn't have multiple inheritance, but it has mixins. So yes, mixins allow you to provide a constellation of methods to an object. Java has interfaces. Doesn't have multiple inheritance, but it has interfaces. So in Python, abstract base classes can be used to define interfaces. You can do this informally as well, just duck typing. The object expects a method. Then you just provide that method. We have abstract base classes in our collections module that work as both mixins and interfaces. For example, the iterator abstract base class, it provides a method dunder iter and an abstract method dunder next. In Python 3 and Python 2, it's just next, but still abstract. Any questions? Any questions on interfaces and mixins? Good. Module level dynamic scoping. So things referenced globally through the module namespace represent dynamic scoping in Python. So this is implemented by functions and methods knowing the modules they were created in. Python doesn't have a true global. It has module level globals. Things are global only on the module level in the module namespace. Functions and methods, which are functions know what modules they're created in. That means they can change out from under you. So here's an example of that. We have global variable equals 0. We're going to define a function, return the global variable. This doesn't know it's a global variable, but when the function is compiled, the compiled function knows it's a global variable. We get the global variable, it is 0. We change the global variable to 1. We get the global variable, it is 1. So that 0 didn't get stored in here and memorized here. We just know that we need to get that global data in the global scope. And so that's a lookup. We look it up in the global scope. The function knows the module it was created in, which is the main dunder main module. This is the entry point of a Python program. That's the name of the entry point of a Python program. We can disassemble and look at the bytecode of the function. We see that yes, we are loading a global variable. This is dynamic scoping with module globals. Yes.
How do you create a new binding of that global? Of that?
How do you create a binding, like a closure?
No, a new binding of it.
A new binding of what?
Within the context of that function. That's what dynamic scoping means. It means that when you rebind the value, it's when you call a function inside of that, then that rebound value is visible, but outside of it, it's not. Right?
I think maybe your question is going to be answered by my next couple of slides. I don't know.
Dynamic, the very last line where it doesn't matter if it's inside or outside.
Or you leave that.
No. So if you read down the global variable inside of get global bar, and then you call that function and then you value, you would see the new value in the global bar.
Yeah.
It basically means that at one time the way it works is you go down one time stack and look for the first occurrence of that value.
Yeah.
And that's how you determine the value.
Right. I was wondering how.
Well, what's happening here is the function is doing a lookup in the module in the global scope, and it's saying, oh, the global scope is 1, and we're going to return 1. Okay, so we get lexical scoping with closures in Python. Functions defined by other functions close over variables in that scope. In Python 3, you can modify closures with a non-local keyword. It is otherwise, for example, in Python 2, it's an immutable binding. Functools.partial provides another way of binding arguments to functions, but I don't go into that. I just describe lexical scoping. So we have an outer function that takes an argument. Inside of the outer function, it will create an inner function that will return that argument. And when called, the outer function creates this function and it returns that function. And so when we pass 4 to outer, this function gets created. That argument gets bound into this function. And then when we call that inner function, we get 4. When we pass another argument to outer, that creates a new inner function, which binds that argument, and we call that, we get that function. We still get 4 when we call return 4. That's because the function object remembers the value that was passed to it. It remembers the object that was passed to it. 4 is an object. 5 is an object. Remember, in Python, everything is an object. And so in Python 3, the non-local keyword would allow these to be modified. So we could do non-local arg, arg plus equals 1, then return arg. And it would remember that. Yes?
Return inner is returning a function object?
Yes. So this function gets compiled into a function object. And inner is the function object that gets returned. Absolutely.
If I looked at the type of that Python, it would be some...
If you looked at the type in Python, it would, if you did type of return 4, it would say it's a function. And it's a function that knows its own name. It has this closure attribute. It knows its own name. And if we added documentation here, it would have a doc string on that function. Okay.
Go away. If I call it again, let's say ret 4.1
Mm-hmm.
out of 4, the two, ret 4 and ret 4.1 would be different functions.
Yes.
Would that be
Yes.
Every time you call it, you get a new function.
in new instantiating? Yep, yep.
Yes. It's a new instance of a function. Python, everything's an object. Okay, so I kind of want to take a step back and take a look at the structure of the source code of Python. So if you go to CPython source code, you're going to see these directories in the version control. The first is docs. We have incredibly good documentation. I think it may be the best of any language. I could be wrong, but I think it may be the best of all the languages out there.
How many languages do you know?
I'm just saying, it's really, really good. I could be wrong, but I doubt it. Yes, what's the question?
Yeah, when you say we, when you're talking about Python, are you a contributor to the editor or the...
I say we, I use we a lot. I mean, we is the people of Earth. We, the people of Earth. Well, I mean, but literally, we, the people of Earth, kind of own Python. Well, yeah, Guido van Rossum owns Python. I'm sure he could, do something screwy with that. But in its current form, he can't take it away because of the licensing. So I would like to contribute. I've filed bug reports. Well, one bug report. I'd like to fix it. I submitted the bug report with code that would fix it. I don't know if they're going to let me. I'd like to submit it as an actual patch. But anyhow, back to the source code. I'd like to say I've read every bit of the source code too. I haven't, but it's huge. There's an absolute lot here. The documentation, it's got a basic tutorial. I recommend you start at chapter 3 if you want to go through the Python tutorial. You can read chapter 1 and 2 if you like, but it's kind of those chapter 1's too short and simplistic to point people at. Chapter 2 is seems like it's way above everybody's heads. People who are new to programming. So start at chapter 3 on the tutorial, go all the way to the end of the tutorial. Then look at the library reference, which has the built-in functions. It's got the specs for the built-in functions. It's got the all the standard library. Then you have the language reference, which has the syntax and the grammar. And so actually the grammar directory is actually a very small directory. We have a grammar file that we include in the documentation as well. We include another copy in the documentation because it's so useful to be able to look at how the syntax of Python is created. It's only about 2 full screens of code in the grammar file, and everything is basically recursively defined. It's really pretty awesome. Include has some C headers. Lib has this is where, like, if you want to see the source code of most Python that's written in Python, this is where you'd go. You'd go to the lib directory. Modules, we have the portion of the standard library that's written in C. We also have some in Python. In objects, we have the C source for Python objects, so you can see how a list is implemented. It's not a linked list. It's basically an array of pointers, which is really efficient for popping things onto the end and taking things off the end. Really inefficient if you want to do operations on the front of it. And so if you want to do that, then you'd use a deck object from the collections module. Deck short for double-ended queue. Okay, so objects. Then we have the parser, which has the C source Python grammar parsing. Programs, which has python.c, and the main there calls pymain. I'm going to hand wave a lot here because. Then we have tools, so we got a number of useful Python programs, and even tools demo, which basically has a collection of demo scripts.
So basically everything, or almost everything, is written in C, and Python was...
This is written in Python. The demo stuff is written in Python. Everything in lib is written in Python. And that's pretty big. Lib is pretty big, yes? Can't tell you that. Huh? Yeah. The question was what percentage are each things, and I don't know. I know this is really tiny. I know this is really big. This is pretty big. This is kind of big, not as big as this. Just look at it. It's great, Run word count on each thing if you like.
Use Python to do it.
You could use Python to do it, yes.
Or just open a GitHub, can't you? You just click the bar.
Okay, so the C base, we have the built-in functions are written in C. Low-level base objects are all written in C. Some modules standard library. The collection has collections module has objects that are written in C, but a lot of it's in Python too. Okay, another important point about the C base is global interpreter lock, commonly referred to as the GIL, prevents multi-threaded code from running on more than one processor. We have real OS threading. We have real OS threading in Python.
Okay, and you prevent them from running on multiple cores?
Yes, we prevent them from running on multiple cores.
Why would you do such
They're trying to take it out. It turns out that 20 years of having the GIL makes it really hard to remove.
So you probably didn't have native.
They're calling the project the GILectomy.
This might explain why it was hard to get more nanoseconds.
I'm guessing you probably didn't have native threads originally, and they had to kind of scheduler that did the threading itself.
Maybe.
In which case
We had problems, yeah.
In that case, you probably would not want that on some project.
Yeah, well, this solves a huge class of a whole class of bugs for multi-threaded programs.
Bugs or features? Bugs or features?
We're trying to exercise the GIL. Excise it.
Processes are really threads, right?
Processes. Yes, so if you want to use multiple processors, you can use the multiprocessing library. And each process is its own Python process. And so it doesn't scale as well as you might hope. But it does scale. particularly if you want that, and things are like I/O bound as opposed to, network bound. And that's where your bottlenecks are. Yes.
I have a real question. Actually, I have two quick questions. What is it, a PyC file?
What is a PyC file?
Python compile, right?
I think so.
Okay. You don't know what's in it?
It kind of changes between Python 2 and Python 3.
Okay.
But I think PyC is a compiled module that's been turned from the Python into bytecode.
The other thing is, can you call C directly from Python? Is there some kind of FFI?
Yes. Foreign functions you can call into any. Something written in any language with foreign function, basically.
C++ function?
Yes, absolutely. And C and C++, you can release the GIL. So that's our workaround. That's our workaround. You got a bottleneck. You're constrained by the GIL. You got to write it in C anyway, right? You can release the GIL. Okay. The Python lib. All right, so most of the standard library is implemented in Python. For example, threading, multiprocessing, much of collections. So this is how we create packages in Python. Packages are created, basically they're directories with a dunder init.py file. That can be empty. In fact, it'll even work without the dunder init.py. Instead of being a package, though, it's called a namespace, but it'll work just the same. So packages are executable like scripts with a dunder main.py. Yeah. Did I skip? I skipped one. So we create the directory. We create our init.py. We create a main.py. We tell it to print the name. We do that with a here doc. And when we do Python demo, we get the name of the main entry point, which is main. And I think I skipped this. Executing scripts. So this is a typical way we get started writing Python. Just basically create a file called something.py, like demo.py, and you have your Python code. And then when you call Python demo.py, you get that code executed. And so we usually call these scripts. These are definitely packages.
So what is a package? Just a Python file or a module? What's the difference?
Not too much difference. You can basically get the same semantics with a package as you can with a file, a single file.
It's just another level of nesting.
Yeah. It allows you to give another level of nesting. You can break things up, put your dependencies in one thing, put your main process in another thing. All right, but forget that way of executing Python modules. What I would suggest you do. I didn't test this code, but this should work. I got to adjust the path. So use my home directory for the path. Is that right? Does that look right? Looks right, right? Right. Like I said, I didn't try it. All right, but this puts where we are on our path. So we just create, we make a directory importable. We make another directory package. And then we create a file here in our folder structure, print module name.py. And we tell it print name and a file. And then when we execute the module with -m, it executes this as if it were imported as a module, and then we call the main function or just execute code in the main module. And so this is really the best way to work with a large Python code base. You want to develop a package. You want to put it in a certain nested point in your code. The right way to do it so that all your imports stay consistent and sane, keep your sanity, is to use this module style importing or way of running your scripts. Okay, so we have a lot of command line tools that also use this -m argument. So these are from the docs, the JSON docs. Particularly, you can pretty print JSON into, say, another file with Python -m JSON tool. Just pipe text right into that, and it pretty prints your JSON. We can benchmark Python code on the command line with the time it module, and then we have some setup and the benchmark code. This is straight from the docs. I didn't try them out. Ran out of time, I think. All right, so we can use standard in for improvisational Python. This is pretty cool, I think. If you're given a live demo, like I like to do, and I don't want to leave my command line to create a file, and I don't want to actually create a file that's going to stick around. So I just, do a here doc and pipe it into Python, and it executes like it's a module. So that's pretty cool. You can execute arbitrary commands, arbitrary Python commands. Not complex statements. Look at the grammar file for what complex statements are. We're going to look at a lot of complex statements in just a minute.
Isn't there like a proper REPL for Python?
Yeah, you're going to see that in a sec. I think I've already shown you, but yeah, we're going to see that in just a sec. But yeah, right. So like right on the on the bash command line, just execute a little Python. Why not? You like that?
Script kings love it.
Yeah. All right. So in Python we have if, elif, else. That's pretty cool, right? I don't know. This seems pretty basic, right? Everybody's good on what if, elif, and else is. We can have any number of these. These are optional. Else is also optional. You do if foo, if bar, if baz, whatever. All right. Exception handling. Exceptions are commonly used for control flow in Python. That's pretty cool, right? It's integral to the language. It really is. If you want to do a for loop, in Python, when your for loop runs out, it's an exception that stops it under the hood.
How elegant.
Yep. Python's pretty darn cool. All right, so it's frequently used under the hood. So it's really great because we want atomic operations to avoid race conditions. And why would we want atomic operations in Python?
Yeah, we don't worry about race conditions.
We do worry about race conditions.
Really why? You have the guild.
Yeah.
No.
Yeah. You have race
No.
conditions and you have a guild?
Sorry.
Well,
the whole idea of the guild.
You can have multi-threading on a single you can have multi-thread in a single core and still have race conditions.
This is true. But you have to work at it.
No, you don't. No, you don't. Threading is hard. I've worked on some threading code. It is not easy.
I agree.
It is hard.
But doesn't the guild save you from that? No.
It does not save you from that.
It allows threading, not multi-core processing.
And you just think it's huge. You have to have Compatibility to kill race conditions.
Anyhow. So yeah, so if you want to do see if a directory is there before you write a file to it, and you check to see if the directory is there. Well, actually, what Python does is it like raises an exception, or tries to open the stuff there, and it raises an exception. That's what it does. It's testing for exceptions under the cover, anyways. And then it tells you, oh, there's no directory there. There is a directory there. But if it says there's a directory there, and then you go to write that file there, well, the directory might be gone. That's a race condition. It's much better just to try to write the file there, and if you expect the directory to be there, then maybe you handle if the directory is not there, then maybe that's something you'd raise, or if it's just could happen, then maybe you then create the directory and try to do it again. And so, and our try excepts, okay, so this is a more generic one, and maybe we want to raise here. So a bare raise preserves the traceback. Then we can have an optional else clause in our try except else finally. Else basically means there is no exception whatsoever. Then else will run. You might stick it here at the end of your try block. That's code you could, and without the else, you probably would stick at the end of your try block. Why is that bad? Well, what if that part raises an error? Then you've hidden a bug that you're trying to, you're trying to handle another bug or another error, but you've got a different error, and you're trying to handle an error that you didn't think was there. That's why we have an else here, and we have this code here. Then we can execute code that we would have put here after where we would have expected that exception. Then we have our finally. Finally gets executed no matter what. If I put return, if this was in a function, and I put return foo here, and in else we had maybe return bar, and we didn't have an exception, it would calculate what bar is, then it would calculate what foo is, and return foo, not return bar. Finally is guaranteed to happen. Okay.
Before you go on,
Yes.
what's the flow of, what's the thread of execution here? You go try, so you
Top to bottom.
So you do staff. If it has no exception, do no error, and then do no matter what.
That's right.
And if you did have an exception, it'll do.
Then maybe you could have handled it, and then you do the finally.
Okay. And if you stuck the else in the try, what would happen then?
The else in the try?
Yeah.
And no error result.
If you stuck the else,
Isn't that what you suggested before?
no. Oh, if you stuck no error result here, you could say no error result here,
Okay.
but then you wouldn't have that else.
Right.
It would just be no error result. And that's probably where you would put it if we didn't have the else.
Fine.
His point earlier was about if there was an error in the no error, if that raised an exception there, there's nothing to catch.
Well, right now there's nothing to catch it. You got also.
Yeah, so the point is, having nothing to catch an error here is a good thing because we don't expect an error here. We want to fail noisily because we follow good best practices when we're writing code. When there's a bug, we want to know. Okay. All right. We also have context managers in Python. So the simple basic example is open in the built-in functions. With invokes the context manager on whatever object that you got here. This object will have a enter and an exit, a dunder enter and a dunder exit special method. The dunder exit can handle errors. And what we get here when we do asf is whatever this returns in the dunder enter method. It's usually self, but it could be something else. In this case, it's our file object, and because we opened for writing, we can write. And what the dunder exit method does is it, in this case, closes the open file. When I was first learning Python, context managers were really new, or maybe they weren't even there yet. And I knew, okay, all I knew was you open a file with file, I think. And maybe then someone said, no, use open. I'm like, oh, okay, f equals open. And of course, I've got some kind of stupid error. I make, some kind of stupid error. But, I'm really stubborn too, so I refuse to exit the shell so the file closes. And I stay there and I fight with it like for an hour trying to figure out what is wrong, why can't I open the stupid file, what's going on here? And I just fought with it because I'm really freaking stubborn, and apparently I had the time. So I wasted a lot of time. And I was a little bit unhappy with the guys who didn't tell me about context managers, and I was also kind of mad they didn't even tell me about exception handling. I was like, gosh, guys. I think they were on IRC, so I really didn't have, I couldn't shout at them effectively. But, and anyway, context managers, really cool. We like to use these things to, say, bundle transactions in databases.
Does this use a specific interface? I know, like in C#, this would be like a using statement. You have to implement I-dispose. Does like the open have to implement some sort of interface for that object that returns back?
Yes, the interface is the dunder enter and the dunder exit.
So the exit would be executed on completion, like when you leave the scope. Dunder exit would be completed and dunder open obviously when it starts.
When you leave the scope, dunder exit is executed. Right here, dunder enter is executed. I could have said like open result equals open file name W here, and then I could have said open result here, but that is when the enter is executed. Whatever's returned from the enter is given here. And then when we leave the scope, I mentioned the white space is important, right? No? In Python, white space is very important. In a lot of languages, it's not. Make files, they use tabs. There's a little precedence, right?
Do you have to convert your tabs to spaces?
Not in make files. That'll screw up your make files.
But elsewhere? No.
In Python, I recommend using spaces.
Yeah.
In make files, tabs. You got to use tabs. Okay, so.
So is it true that dunder exit executes regardless of whether dunder enter gets narrowed or not?
Dunder exit will get executed no matter what, and it'll take a few arguments. It'll take, I think, 3 arguments. One is like the exception type, one's the exception instance, and one is the traceback object. Maybe I don't remember. Traceback object is the 3rd argument. It takes 3 arguments. If you return falsy, then I think it re-raises. If you return true, it will squash the exception. Anyhow, okay, so how we do data streams. All right, here's where I said we kind of replaced map and filter with the syntax of the language. All right, so list comprehension is fast. It does take up memory. It's eager evaluation. Thank you, Evie. So let's start here with the interval. This is our data source. This right here is the data source. It's something that we're going to iterate over and pull data out of. We're going to filter on this expression here. This is basically a lambda. It's an unnamed function that if it's true, if it's truthy, we're going to get it in our data stream. If it's falsy, we're going to exclude it from our data stream. And then map goes in this part here. This is, again, an unnamed lambda. And because this is a list comprehension, see the square brackets, that's very important. The square brackets make it a list comprehension. You could use curly braces, and then it would be a set comprehension. You could have a colon in here with a key and a value pair, and then that would be, with a curly brace, that would be a dict comprehension. But here with the square braces this is a list comprehension. The comprehensions materialize all the data all at once. It evaluates everything all at once. But we can do even better than that if we don't want to evaluate it all at once. And I would propose for production code, probably don't do that. So say we open a really big file. A really huge file, so big, we can't store the thing in memory. If we tried to do this with a list comprehension, we'd get a seg fault and Python would quit. And maybe our OS won't upchuck if we're using Unix or Linux. So the generator expression basically allows us to in place a filter lambda and a map lambda right here in this, that's returned in this little object here, gen. And then we can just iterate over stuff that's been filtered with and had a function apply to it. We could iterate over that. We could return this object. We could, what?
Is there a difference between an iterator and generator?
A generator is an easy way of implementing the iterator protocol. So this implements the iterator protocol. It has essentially, I think, actually I kind of mentioned that when I discussed the abstract-based classes. Iterator provides the dunder iter method and an abstract method next. So a usable iterator will have next implemented, and what next will do is you call it and it returns the next thing from that object.
Really sorry.
I forgot to admonish everyone to turn off your phones. Thanks for reminding me. So when it runs out of things to get next, to call next on, what it does is it raises, I think it raises stop iteration, which is basically what I was describing as we use these exceptions under the hood. It raises stop iteration, and then we stop iterating. So this generator expression provides you with an iterator object. As soon as it runs out, it's going to continue raising stop iteration every time you try to call next on it. Here's a generator function. So a generator function, just like a regular function with a return in it, except when we stick a yield in here, and we're going to have maybe something we iteratively yield on. We could do it with a while loop too, or we could do it in slightly other ways too. When we have a function that has a yield statement in it, actually I'm sorry, it's a yield expression now. When we have a function with the yield expression, it becomes a function that returns a generator object when it is called. So when we call this function with any number of args, we will then have a generator object that we can iterate over. So we're iterating over this generator object that's returned by this function, and basically it calculates the function, stops at the yield. We get that here in our iteration. We print that. Then this continues the execution until it gets to the second yield the second time, and then we get 2. And then it continues execution until we get to the 3. We print the 3. And then the function exits, returning none, and the generator object is internally raising stop iteration, and we stop iterating.
You turn that into a lazy evaluator.
It's a lazy evaluator, yes. It's a it's a way of processing data streams. So you can do a lot more complicated things than just mapping and filtering with this.
I mean, it's not entirely lazy work because when you pass in ours is not going to be, unless ours is itself lazy.
It's a list. It becomes a list. So we would say function. So it expands the. It'll take any number of arguments.
Will expand them.
And then it says, okay, we're going to take all these arguments and we're going to put them in a list called args.
Right, so
Maybe it's a
call that
tuple.
function with a million arguments. There's
Yes.
nothing lazy about that.
There's nothing lazy about that. No.
Just want to be clear.
Yes. No. This is where we might, take a data stream.
Yeah.
That'd be very, very large. We would hopefully pull. You want to be lazy with your data. If you're going to sort your data, you can't be lazy with that. So you want to be smart about being lazy with your data.
You want to be smart about being lazy.
Works for me. I loved Scrooge McDuck's admonition to his nephews: work smarter, not harder. Loops have else clauses. They do. This is great. It helps remove a little bit of accounting. When your loop exhausts itself without a break, it'll run what's in the else clause. If you break out of your loop, the else clause doesn't run.
So how is that different than just having a statement after your loop?
Well,
Or is it
how's that different from a statement after the loop?
Wait a minute, if you break,
No, he said just exception, you don't have anything else.
but if you break, you don't run through the else.
Yeah.
After the
Oh, I
loop,
see, you would.
Yeah, I mean, you'd have more code afterwards that you would want to run if you broke or didn't break. So like if you were going to break and you wanted to do something without the else, then you would probably have a condition. If break condition broke equals true, break. And then if broke, so loops have else clauses. It's pretty nice. I've used it a few times. It's pretty wonderful. Even at the end of a function that doesn't really return anything, just works by side effect or whatever, or the function would return true if the thing exhausted itself, or would return false if there was a condition. I think it's just kind of nice to indent the and have it look at like kind of the same parallel point in the execution.
Here you are showing kind of the cool features.
Yes, we are doing, that's the name of the section, features of Python. Cool features. Well, you're a bunch of programmers, and I presume you can learn Python on your own, but I'm trying to get, jumpstart you. Yeah, why not? All right, so, and we're really close to the end, because now we're talking about descriptors. All right, so a dotted lookup, when you do, man, did I even describe any dotted lookups? I don't think I did. Everybody knows what a dotted lookup is?
no.
Do I need to?
Yeah, it looks like you're going to have to describe it.
Man. All right. Okay.
Python 2? You don't use Python 3? Sacrilege.
Yeah, I just typed Python. I'm using Ubuntu. Huh?
Do you have a preference for 2 over 3 or 3 over 2?
I use 2 at work, and it's sort of not a choice. So it's what I live in, and I know.
If you want water over here, I'll get you.
No. We'll do that in just a minute. All right, so okay, so we're just going to make a class foo, and it's going to have an attribute called bar, and we're going to instantiate foo. And we're going to do foo.bar. Okay, so what actually happened there, can we scroll up some? Woohoo. All right, so what actually happened here was we did a dotted lookup. This is an instance of foo. F is an instance of foo. What happened was we looked, when we did dot here, we first looked in the class foo for if bar is a data descriptor. If it is a data descriptor, then we can use this get, set, or delete, whatever, and a data descriptor has a set or delete. So the data descriptor could control access to what we really want. So that's what the descriptor.
I got your dotted, but now what is dot delete? How do you do dot delete in your previous example?
How do we do?
I got your get. So in your example.
Yeah, del. Keyword del, del. Will invoke delete. So if we did del f.bar, we would invoke The delete, if it is a data descriptor.
Thank you. Got it.
So this is how we sort of handle properties in Python. Do I need to describe what properties are?
Delete the value bar or?
Yes. Well, that's the semantics of it. That's the semantics of it.
Put a null value there?
But you could make it like store it in a safe place, and then say, instead of deleting that attribute, I'm going to just change it to none.
Not the value.
Well, so
You have a property called bar with the value bar.
Is it each the property? Or
You can show them on the reference.
which more the reference?
Type it, you'll see.
I know I could show them on the REPL.
I mean, do you understand my confusion? Like, is it deleting the value or the property?
It's not deleting the property object. Okay, so the descriptor would be in the class definition.
Yeah.
So
it's not deleting a
the descriptor object would be in the class definition.
So what
So
happens then if you do the DL foo.bar?
Yeah, can you actually do that?
let me see if I can, because it was hard to read, wasn't it? Come on. Okay. All right. Bar equals bar.
Okay.
Property def as
Itself like this.
yeah. Okay. Okay, so f equals foo. F dot bar is naturally going to return bar. F dot baz should return baz. Okay. Okay, so we can delete. I'm sorry. We can say this is a class attribute here. We could say f dot bar equals my bar, and do f dot bar. And if we do f dot baz equals my baz, we basically have protected the attribute.
Because it said self. It's probably
No, not because it's self, because this doesn't implement, property is an object that does not implement a setter.
okay.
Unless you explicitly write one.
So now
What
what
if you
happens?
delete bar?
Right.
You can delete it too.
What if you delete bar?
You'd have to, so it would uncover the class attribute. It would stop being my bar and go back to being bar, and then we could delete it from the class if we wanted to. In the case of Baz,
Oh, I see. Deleting the value of the attribute.
so the way decorators work in Python is we did essentially the same thing as if we had said define this function here without that, and then said Baz equals property Baz.
So you cannot do delete foo.bar right now?
Yeah, you can. F dot bar, remember, is my bar, and if we delete it,
Yeah.
then we do f dot bar. We have uncovered the class attribute, and now it's just back to bar.
And what happens if you do it again? Delete.
Yeah.
If you try to delete f dot
Yeah.
baz,
No, F the bar.
oh, well, that's not going to work. It's, I mean, it's, yeah. We have an attribute error.
You can't delete it off the class.
Huh?
You can't delete it off the class.
Fine.
You can even delete it off the class.
You can delete it off the class.
Own that line name.
Oh.
but you have to delete it using the class name.
Oh,
You
rather
can
than
do that. You can do del dot bar, and then, yeah.
Okay, so
So you could do capital foo, capital F foo dot bar dot delete.
oh yeah. Like,
That would delete the attribute.
well, it would be del foo.bar, like that. And now we're operating on the class object.
Wow, that's cool.
And now when we do f.bar, we have an attribute error.
Okay, so now you have removed, yeah.
So and the way that works is, the way this dotted lookup works is it first looks at the class. It says, is there a data descriptor like property? If not, then I'll look in the instance dictionary or slot if it defines slots for it. I don't have a slide about slots. I intended to. What?
First, then the instance to look it up? It wouldn't look at the instance first, then the class?
It wouldn't look at the instance first and then the class. No, it looks at the class first. That's how it does this. That's how it knows to use.
Delete it from the class while it's on the instance, it would automatically be deleted from the instance as well.
It's not clear.
If you did that, you're shooting yourself in the foot.
Yeah. We talked about that.
You wouldn't want to do that. You wouldn't. You wouldn't want to delete bar from the class unless you really know what you're doing. And this is really what you want to do is delete from the class.
So you want to
Okay, so it looks in the class. Then it looks for a data descriptor. If it's not a data descriptor, then functions, for example, are non-data descriptors. They are descriptors, but they're not data descriptors. They have the get, which means you can sort of overwrite a function on an instance.
Okay.
Probably don't want to do that, but it's doable, and that's how this is implemented. That's how the dotted lookups are implemented. They're implemented with descriptor objects that have get, set, or delete. And that's how we implement class method, static method, and normal functions and property.
Where static method spans across instances.
Static methods expand across instances. You can call them from instances, yes. Yes.
The class method, you call it from the class, right?
You can call it from the class or from the instance. And it'll use the class. Okay, so, and we are moving towards gradual typing. In Python 3, we have function annotations. This is a change in syntax. So,
Is that like official, it's going to happen 100% for sure, or something that
this has already happened.
Yeah, you can decorate it.
This is what we are moving toward.
But at first, we're going to...
So 50% chance?
In 10 years.
I'm not assigning any percentages. I'm making no forward-looking statements. Past performance is no indication of future returns.
Python 2, just moving on, everyone moving off of Python 2 onto Python 3.
Right.
You know what? So you're right. What that basically means is, as long as people are really using Python 2, we're probably not going to get any results from this. And in 5 years or so, when just about everybody's moved off of Python 2, we hope we should, start seeing something along those lines. It could be, it could be today, but it's not. It's not going to work in the business world where everybody's still using Python 2. So we have type annotations. We have function annotations. So the types, as I give them here, like this can be string, this can be int, this can be float. They can actually be any expression. You could have this set dynamically with a, in a closure, for example. But implicit is the idea that Python or some other implementation of Python will be able to use these to compile Python to C or some other language, some other typed language. All right, so in summary, Python solves almost all the problems. Right. You have a lot of hardware. You can scale Python
You can run
pretty well.
Python on different processes, right?
Yes. Oh, yes. Like, what? I mean, it takes a lot of time. Hey, it takes a lot of time to write really well-performing multi-threaded code, doesn't it? In C and C++. It takes a lot of time
No, it takes a
to
lot
get.
of time to debug.
Okay. It takes a long time to write code that works consistently.
Just debugging.
Consistently. The point is that developer time is becoming more and more expensive, and hardware is becoming less and less expensive. And that's a huge win for Python. I saw this coming. That's why I went with Python. It's one of the many reasons. Okay, so if it's not fast enough, profile and optimize for the bottlenecks. Final main point is use Python. Thank you very much. Cheer for Python, all right. I think we have no time for questions? Two minutes for questions?
One or two.
Okay, what's a quick questions? In the form of a question, please.
You seem to have gotten some flack about the GIL of Python, but you should mention there are versions of Python that don't have GIL.
Yeah. Okay, yeah. So there are versions of Python without the GIL. Implementations of Python.
They include JSON and R and Python and PyPy currently. Oh no, PyPy has GIL.
Okay. Yes.
What's the concurrency story in Python? Are there like semaphores, mutuxes in the stem library? Or?
Yes. Yes. Threading.
So then, how does it scale to handle like web requests when you have to like handle like the C10K problem?
I think
One computer 10K.
the Twisted library is really good with that, but unfortunately, it hasn't been fully moved to Python 3. But since those things are network bound, it's a really good use case for going with concurrency in Python. And Python threading is the most efficient way to do concurrency in Python.
So the GIL, do you just end up doing like a web garden where you have multiple instances of Python running, and then you just have kind of a master designating you do this, you do this, you do this, you do this?
You don't need to do that with that. I mean, if you use Twisted, it's almost like cooperative multi-threading, but it's a little more complicated than that. But it doesn't like most web requests don't involve long computation, right? So you're going to constantly be going through the C layer. So it's going to keep switching threads, and you are going. And even then, if it doesn't, you're still going to come back very quickly with the result. If it doesn't hit the disk or whatever, doing I/O, it's going to compute a result pretty quickly in most cases, unless it's some complicated application server.
Okay. Any more questions?
Yes. Maybe you can talk about like virtual and stuff, like on environment replication stuff's really handy.
Yeah.
Like,
Virtual environments are cool.
Yeah, they are very cool.
And Python, it's got that. And standard library.
Higher order functions.
Higher order functions?
Yeah.
They have them.
Yeah.
What are you talking about?
You
I demonstrated them with returning a function. Yeah. Yes.
Could you give your opinion about why the community has had so much trouble moving to Python 3?
Oh.
It's been-
I think that's a bar question.
there are still places that are 5.4.
Because they make applications.
Yeah, and all the
Thank you, Aaron.
Maybe we'll do that for you.
All right. All right, so this used to be the wall of shame. This used to be the wall of shame. This is why this is one reason, aside from the fact that when a business starts using one version of Python, they don't want to spend any money. If it ain't broke, don't fix it. They don't want to spend any money upgrading their code. And of course, their programmers were probably did not care about writing forward compatible Python. They wanted to check the box and get on to the next thing. This used to be very red. It is not as red anymore. There are some red. Yes, there are some red ones. All right, but here it is. That is really green, and now that is why they decided to go ahead and change their name from the Wall of Shame to the Wall of Superpowers. So this and just the slowness of how business runs is why we've had trouble getting to 3.
Is there something popular in Python 3 that they just go and backward into Python 2? So
Well,
what are the reasons that?
for the standard library, they're only backporting like security fixes, and that goes away in 2020, and or in theory that goes away in 2020 unless maybe somebody ponies up some big bucks for it.
But what's to prevent? I mean, it's open source. What's to prevent someone from just saying, "Yeah, I'm backporting the Python 3"?
Well, you can go for it. Your own little GitHub thing. Good luck maintaining it. Yeah, so what happens is when new things get put into the standard library in Python 3, the backports go to the Python package index, PyPI, and that's a simple pip install. So you create a virtual environment and then you pip install things. You don't pip install into your OS. Although I understand that, like Ubuntu, if you pip install, it installs to your user area, not into the OS area. Yeah.
It seems like it's...
Somebody grab me a Budweiser before we get kicked out of here.
It solves almost all the problems. So what is it that doesn't solve?
What?
What is it that Python doesn't solve?
What is it that Python what?
Doesn't solve.
Instead of solve all the problems.
What is it that Python doesn't solve? It doesn't solve its own bottlenecks for you. So you gotta solve your own bottlenecks. Like you're probably not going to write an OS in Python. I think there have been OSs written in Python. You're probably not going to use an OS written in Python. You're probably not going to see a rewrite of Apache in Python. That doesn't make any sense. There's some things, the problems have already been solved in C, and if they've been solved in C, you want to keep using them in C. You don't want to reinvent the wheel with Python. But if you're trying to solve a new problem, Python's a good way to get started. All right. Thank you very much.
If you want to keep the discussion going, please join us at the bar here. I totally forgot, but you have an announcement to make?
Yes. We are having a party in July. So I run a meetup group called, in 2 weeks, yeah. I run a meetup group called Lisp NYC. I used to actually run this meetup group as well. And every summer we have a huge social in which we invite all these meetup groups, including Lisp NYC, Clojure NYC, Haskell NYC, Erlang NYC, OCaml NYC, and languages, and the papers we love folks. And it's actually on my roof deck on the Upper West Side. It's on July 19th, and you can sign up through any of the meetup groups I just announced.
What about Clojure Bridge?
Oh, and also for those women that are here, we are having a Clojure Bridge, which is a workshop for women to learn how to program, specifically functional programming, and that is actually happening at the end of July.
And where would you get more information about that? Is there a website?
There is.
Clojure Bridge.
Yeah, you have to Google. You know what? I'll send you the link and you can announce it.
And if you can't get enough of Aaron, he's speaking at PyGotham.
I am speaking at PyGotham, guys. Tickets are not sold out. It is the 16th and the 17th of this month. If money is an object to you getting there,
But all things are an object.
There are need-based scholarships you can apply for, and they are generous. And we give away free tickets to people who need it. Right. If you're a super wealthy hedge fund manager, you should probably buy a ticket. Tickets are half the price of last year. We're doing it at the UN. There's going to be 500 probably people in attendance, and so no reason not to attend. Come to PyGotham. It's Saturday and Sunday, 16th and the 17th. My talks I've almost started, so yeah.
All right.
Cool.
Great. All right.